Hello good day viewers. In this tutorial we are going to learn how to divide a complex number by another complex number applying the Moivre theorem, and we have only one problem in this tutorial. We are given that z1 is equal to 2 minus 2i to the power of 2 and z2 equal to -1 negative root 3i to the power of 3, and we are asked to divide z1 by z2. Before we start, let me show you the formula we are going to apply in dealing with this problem. It stated that if you have a complex number z1 written in its polar form, which is r1 multiplied by cosine of theta 1 then plus I sine of theta 1, and another one z2 which is given as r2 multiplied by cosine of theta 2 plus I sine of theta 2. According to the Moivre's theorem, if you wish to divide z1 by z2, it is equal to r1 divided by r2 multiplied by cosine of theta 1 minus theta 2 then plus I sine of theta 1 minus theta 2. So this is the formula we are going to apply in dealing with this problem. So first of all, let us transform each one of them into its polar form. We have the first one here, z1 equal to 2 minus 2i to the power of 2. What is r1? That is the modulus. It is going to be the square root of the real part, which is 2 squared, plus also the imaginary part squared, -2 all squared. This is 4, this is 4. 4 plus 4 is equal to 8. Square root of 8 is 2 root 2, right? So therefore r1 is equal to 2 root 2. And what about the angle? Theta. If you observe, this angle will be in the fourth quadrant because the real part is positive while the imaginary part is negative. So if you take first quadrant as reference, we're going to take all positive values here. But you have to subtract the result from 360 degrees because we are in the fourth quadrant. So this is 2 pi, which is 360, minus tan inverse of what? 2 divided by 2, that is imaginary part divided by the real part. And 2 divided by 2 is equal to 1. Tan inverse of 1 is pi divided by 4. So we have 2 pi minus pi divided by 4. Which is equal to 7 pi divided by 4, right? Therefore, our angle is equal to 7 pi divided by 4. And this angle is theta 1, remember. Z1 equal to R1, but what is R1? 2 root 2. Then multiplied by cosine of theta 1, which is 7 pi divided by 4, plus I sine of 7 pi divided by 4. But remember, our complex number is to the power of 2, so we are going to square this. Z1 squared is equal to R squared, then multiplied by, you also have to multiply the angle by that power, which is 2. So we have cosine of what? 7 pi divided by 2. If you multiply it by 2, 2 will go into 4 2 times. Then plus I sine of 7 pi divided by 2. Z1 to the power of 2 is equal to, here we have 2 squared is 4, and this is 2. 4 times 2 is 8. So this is 8. Multiplied by cosine of 7 pi divided by 2. Plus I sine of 7 pi divided by 2. So we are done with the first complex number. Now let us take the second one. Here is the second complex number. We are going to find R2, which is equal to the square root of the real part squared, -1 all squared, plus the imaginary part -√3 also squared. This is 1. This is 3. 1 plus 3 is 4. Square root of 4 is 2. Therefore, R2 is equal to 2. What about the angle? If you observe, this is in the third quadrant, which is greater than 180. So we are going to assume we are in the first quadrant, but whatever angle we obtain, we have to add it to 180 because it is greater than 180. So our angle will be equal to pi plus tan inverse of what? Root 3 divided by 1. We are taking all positive values because we want to use the reference angle. Root 3 divided by 1 is root 3. Tan inverse of root 3 is pi divided by 3. So this is equal to pi plus pi divided by 3, which is equal to 4 pi divided by 3, right? So our angle, which is theta 2, is equal to 4 pi divided by 3. So what about our complex number in its polar form? Z2 will be equal to R. What is our R? R is 2. Multiplied by cosine of the angle, which is 4 pi divided by 3. Then plus I sine of 4 pi divided by 3. But remember, our complex number is to the power of 3, so we are going to take it to the power of 3. Z2 to the power of 3 is equal to 2 to the power of 3, then multiply by cosine of the angle multiplied by 3. 3 will cancel 3, leaving only 4 pi here. Then plus I sine of what? 4 pi. We are almost done. Z2 to the power of 3 is equal to 8 multiplied by cosine of 4 pi plus I sine of 4 pi. But remember, we are looking for what? Z1 to the power of 2 divided by Z2 to the power of 3, which is equal to, you divide their radius. They have the same radius this time around, right? 8, 8. Let me even bring this one closer. So look at it here. Z1 squared divided by Z2 to the power of 3. This is equal to, you divide their radius together. You have 8 divided by 8, right? Then multiplied by cosine of what? You take this, you subtract this. You have 7 pi divided by 2 minus 4 pi. You add I sine of the same thing. 7 pi divided by 2 minus 4 pi. You close. We simplify and get our final answer. 8 divided by 8 is 1, so we only have cosine of 2 multiplied by 4 is 8. 7 minus 8 is negative 1, so we have negative pi divided by 2 here. Then plus I multiplied by sine of negative pi divided by 2. Now let us evaluate this. Remember, this is what? 270 degrees, right? Or what? 3 pi divided by 2. So what is cosine of that angle? It is equal to 0, definitely. And sine of that angle is equal to negative 1. Plus I multiplied by negative 1. And this is equal to negative I, because I times negative 1 is negative I, plus 0 is negative I. This implies that if you divide these complex numbers, you are going to obtain negative I. Should we prove it? Yes, let's do that. All right, here is my calculator. The first complex number is what? 2 minus 2i raised to the power of 2. Then we divide it by the other one. Negative 1, negative root 3 I. To which power? To the power of 3. And you can clearly see the answer is negative I, which is exactly with what we have, right? And this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.